Hello, this luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through linear modeling. So that is taking real life situations that involve linear equations, and we're going to be solving problems involving these. So let's look at this example here. Tradesman charges $50 call out fee, $80 per hour. We're going to graph the relationship between the amount he charges and the number of hours worked, and then we're going to solve a few problems related to that. So let's firstly look at graphing the relationship. It would be so much easier if we had an equation. So let's first write the equation linking y, the amount he charges, and x. So that's actually not too difficult. We just rewrite the information we're given up here, but only using mathematical symbols. So what that's saying is amount he charges is $80 per hour, 80 times the number of hours, plus 50. Now graphing that will be easy. It's in gradient intercept form. So let's set up our Cartesian plane. Once again, we only need the first quadrant because neither the amount he charges nor the hours worked will be negative. They'll only be positive. So we can just call our axes x and y because we already defined y as the amount he charges and x the number of hours worked. So x we'll just do like up to 5 hours. We don't need to keep going forever. So we might go up every second division can be hundreds. Okay, so we know that this is in gradient intercept form, so we know that the y-intercept is 50. So we mark that, that'll be 50 there. So the gradient is 80, so that means every time we go across one, we go up 80. So if I go up, I need to go up to about 130, right? So I can just estimate in questions like these. I don't want to have to go and, do every division from 50, 60, 70, 80, all the way up to 130. That'll take too long. So 130 will be around about there. So I can just plot those 2 points and draw a line through them. Also, because the divisions and the y-axis are multiples of 50, I could keep going until the cost will be a multiple of 50. So, for example, after 5 hours, the cost will be 80 times 5 plus 50, which is 450. So after 5 hours, it should be up here at 450. Either way you do it doesn't matter too much. So then I just plot the points and I have a line here, okay? So you can put an arrow on this if you like because he would work more than 5 hours sometimes, okay? So that is the line y equals 80x plus 50. So the graphing part is done. Now the other two parts are super easy. So how much would he charge if he worked for 4 hours? Well, in that case, 4 hours means x is 4. So y is just 80 times 4 plus 50, which gives you 370. That's easy as. So for how long must he work to earn 770? Well, this time y equals 770. So we just take our equation, y equals 80x plus 50, and we change y to 770, and you know how to solve equations like this because you've done it a million times. You would subtract 50 from both sides first, so I get 720 equals 80x, and of course the way to undo timesing by 80 is divide by 80. 720 divide 80 is 9, so therefore he must work 9 hours. How easy is that? So I'm just going to do one quick example now where the gradient is negative. Please pause and copy this down if you need. So in this example, temperature of water is now 30 degrees, decreasing by 2.5 degrees each hour. How long until it reaches 0 degrees? And we're going to graph the relationship. So once again, I want to come up with a linear equation. So the variables I have here are temperature and hours. So as I said in previous video, whenever you're dealing with time, it always goes on the x-axis. So we're going to let x equal time, and I'm going to let y equal the temperature. So we want an equation linking y and x. So the temperature is 30 degrees now, but it's decreasing. So it's minus 2.5 times the number of hours, 2.5 degrees per hour. That is the equation linking the two. So if I want to find how long until it freezes, now I have y is equal to 0. I just substitute that into my equation. 0 is equal to 30 minus 2.5 times the number of hours. Subtract 30 from both sides. Now when you get here, the number in front of x is not 2.5, it's negative 2.5. So I divide each side by negative 2.5 and get 12 equals x. So therefore it would take 12 hours for the water to freeze. So let's look at graphing this. So once again, I'm only going to look at the positive axis. Now, of course, x, which is time can't be negative, but y, the temperature, well, it can be negative. But we're only interested in going from 30 degrees to 0, so I don't really need to include negative y values. So it's going down by 2.5 degrees each time. So what I might do is go up by 5, because 2.5 times 2 is 5. So if it's going down by 2.5 degrees each hour, it goes down by 5 degrees every 2 hours. So I might go up by 2s for the x-axis. So the gradient here is constant, it's 2.5, so that's why this will be a linear equation. My graph should be a straight line. So we know how to graph an equation like this. It's in gradient intercept form. The intercept is 30, it starts at 30 degrees at time 0, then it's decreasing by 2.5 every hour. So if I go across 1, I go down 2.5, or if I go across 2, I go down 5. Once I have 2 points, I can draw a graph through them. I also just figured out that at 12 hours, x will be 0 degrees, so I could plot that point too. Either way, I'm just going to join up my points. And there we have the line, the graph that represents the temperature of the water. How easy is that? So don't be scared by all these worded problems. They're just using the techniques that we've done a million times in this topic. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.